Here at the Virginia Tech Transportation Institute, we're focused on a core mission of saving lives, time, money, and protecting the environment. We do this through cutting-edge research across a variety of disciplines and domains, all collected within our divisions as well as centers that focus on a variety of topics relating to advancing transportation.
The background of this particular project was a focus on the roadways in the city of Virginia Beach, which have consistently ranked in the top 10 crash cluster locations in the state of Virginia, many of which occurred at signalized, controlled intersections. So the city, like many municipalities, have invested a significant amount of resources in digitizing their transportation system infrastructure, which is evident in each intersection where there is just a bunch of sensors in terms of vision-based cameras, thermal-based cameras, radars, loop detectors, Wi-Fi detectors, Bluetooth detectors, you name it, were basically integrated into the overall infrastructure.
We mainly focus on the video feed that we get from all the traffic cameras all across the city. We have used computer vision and advanced machine learning techniques to process these videos, understand the interaction between all the objects that are in the scene, including the car, the pedestrian, the bicyclists, and then track them over time. Generally, the videos that we get from these traffic cameras, they are highly compressed, they are low quality in general, and they have very high noise. We collected data from different intersections, day, night, as well as on different weather conditions, and we used them to train new object detectors.
I used popular object detectors such as faster RCNN and Cascade RCNN and others, which rely on deep neural networks to locate cars in each frame. These videos, however, suffer from low image quality and high noise. For this reason, we fine-tuned these algorithms specifically for our problem to improve performance. After detecting these objects in individual frames, we also performed object tracking to track objects in consecutive frames in the video. We managed to create a new graph convolutional neural network-based approach for traffic monitoring, in which we improved multi-object tracking through the use of graph neural networks, which take into account the interaction between different objects in a scene. In this way, we can reduce confusion regarding changing object identities in the video, and therefore provide the correct labels for each object. We also improved object detections by using optical flow throughout the video, which essentially helps us track each object in consecutive frames.
Finally, we try to understand their kinematics, their speed, their relative positions, and then try to find out overall safety.
My role in this UTC project has been to convert pixel information from a traffic camera to GPS coordinates on a map, so that we can calculate basic kinematic data from the vehicles themselves. I then use the GPS coordinates from the map to convert the video pixels to those exact points. We use 2D interpolation to then choose every single pixel point that converts to a GPS point. And so we calculated the basic speed and acceleration of the vehicles, and then kind of noticed some interesting patterns where there were certain conflicts in certain areas, and the volume of the cars changed throughout time. So we were able to look at the light patterns of the intersection. And then I was able to actually visit one of the headquarters in DC for the Virginia Department of Transportation, and we were able to see what the traffic control operators look at. And so they're looking at hundreds of video cameras in Virginia. And so if they're able to pinpoint a certain video that they should be looking at, it's very beneficial.
A really neat part about the UTC program that is sponsored by the US DOT is that it allows us to directly engage students in a very meaningful way, shoulder to shoulder with the world's leading transportation researchers, in order not only to get a spectacular education in a hands-on and meaningful way well beyond the classroom, but also to prepare them to take all of those lessons learned, graduate and enter the workforce, and continue to make a lasting and positive impact with the lessons that we were able to teach them here at VTTI.